Let's consider example 3.7. 3.7 is asking us to compute the elements of the Fibonacci sequence. Computing the elements of a Fibonacci sequence is a common challenge problem that I've found for students because it really tests your knowledge of variable assignments. So our Fibonacci sequence is written as such. So the fi, the ith element of f, is equal to f of I minus 1 plus f of I minus 2. So the ith element of f is equal to the sum of the previous two elements. So in order to get started, you have to specify the first two elements, but once you have those, you can compute the rest. The most common Fibonacci sequence starts with f of 1 equals 1 and f of 2 equals 1. Write a script that uses a for loop to compute the first 10 elements of the Fibonacci sequence. As a postcondition, your script should assign the 10th element to answer, and we're told that the 10th element is going to be 55 to test to make sure our code is working correctly. And then we're asked to generalize our script so that it computes the nth element for any value of n, where we can assume that n is greater than 2. So remember, we're assuming the first two elements are 1, and so we'll assume that when we compute n, the n's greater than 2. Later, when we learn about logical statements, we can see how we can build that into the code to prevent users from specifying values, say less than 1, or if you have a value of 1 or 2, that you properly capture that. So let's pause that and let's move over to MATLAB and let's solve the problem. Okay, now here I am in MATLAB where I've attempted to set up my screen so in the bottom we can still see the Fibonacci sequence as printed in the text. So we are asked first to write a script to compute the 10th element of our Fibonacci sequence and then test that. We know the answer will be 55. Once our code's working, we're going to generalize it to compute the arbitrary nth element of the Fibonacci sequence. So we'll create a new script, okay, and this will compute the nth element of the Fibonacci sequence. And I'll make a note that we are assuming that n is greater than 2. Again, once we learn about logical statements, we'll see how we can put in checks to make sure that that's enforced. Excellent. So precondition would be n, the element of the Fibonacci sequence we wish to compute. And let me space that over. As a postcondition, so we're told that answer will contain the nth element. Okay, excellent. Okay, and we're told to set up a for loop. Okay, so. So first, we need to initialize our sequence. So we're told that the first two elements are both 1. And then remember, the ith element is the sum of the previous two. So if I want to calculate the third element of my Fibonacci sequence, that's the sum of the second and first element. Okay. So to get things started, first and foremost, I need to assign to variables the values of the first and second element. So I'm going to initialize a sequence with elements 1 and 2. So fortunately, spelling, let's see. Fortunately, MATLAB doesn't have a spell checker for you. Okay, so I think that's sequence. All right, so F1 will initialize with 1. F2 will initialize with 1 as well. Okay, so just as a check, if I wanted to compute the third element, right, the third element would be F1 plus F2. Right, and so I need to save this. So if I save this as fib n. Okay. And so, actually, if I just write fib n, since it's just summing up the 2, right, it properly sums up the 2. Okay, but we want to compute the nth element, and so we're going to set up a for loop. Okay. Computing nth element. So I know it'll be a for loop, and I know I'm going to loop from beginning with element 3. Why? Because element 1 and 2 are predefined. So I'll start my loop with 3. And I will loop up to the nth element, the element I wish to compute. Okay. So the ith element is equal to the sum of the previous 2 values. So if I call this, well, we're told to store to answer, but let's do fi is equal to, in this case, it would be f2 plus f1. Okay. Then the end answer would be equal to fi. Okay. So let's test this out. Let's set n is equal to 3, and then if I rub fib n, right, it works. Life is good. But if I were to make n a value of 10, it's not going to work. Okay. So if I run it, I get an answer of 2. What the heck is going on? 2 is definitely not equal to 55. Okay. So let's take a look at what's going on. So I initialize the first 2 elements. Now I'm going to loop for I is equal to 3 to n. So first iteration I is equal to 3, and I compute f of I is equal to f2 plus f1. So this is a variable assignment. So MATLAB will first look at the right-hand side of the equal sign, sum f2 and f1, and assign that to fi. Okay, so first iteration, fi will be equal to 2. It'll loop, perform another iteration, at which point it'll do exactly the same calculation. Now that's not what we want to do. Okay, so the issue is after we've computed the ith element, we now need to think ahead to the next iteration. Okay, and so let's put in a comment, thinking ahead. Okay, so after I've computed fi, I now need to think ahead to the next iteration, where when I go to compute, say, f of where I is equal to 4, now the previous 2 elements are going to be I equals 3 and I equals 2. So I need to shift what I'm calling as the previous 2 elements. Okay? So if I even just think back of maybe cooking up some intermediate variables, so previous 1, all right, 1 back, in this case would be fi, the next iteration. And previous 2 would be equal to what I'm calling f2. Okay. Then thinking about how the calculations actually performed next iteration. Okay, this is previous 1 and that's previous 2. Right, that's 1 back and that's 2 back. So we need to update those values. So f2, what's 1 back, is what I'm calling previous 1. And f1 is going to be equal to previous 2 back. Okay. So if I save that, okay, n is 10, I compute fib n, I get 55, our desired answer. Okay. So the trick here, or the trick to solving this problem, is thinking about variable assignments. So I need to know the previous 2 elements in order to calculate the ith. So each loop iteration, what is now the previous 2 elements is changing. So I need to update each iteration what I'm pointing to as those previous 2 elements. So here I've used 2 intermediate variables. I could consolidate this down to 1 if I wanted to. I could just do f2 as, say, fi. And if I were to do that, right, it would still work and give me the right answer. Okay, so the difficulty is, or the challenge with this problem is thinking about variable assignment and remembering how these things work. This will become our poster child and later on when we learn about vectors, which will greatly simplify the notation we can use when computing sequences and series.